Okay, now looking at some problems from 6.3. 6.3 are exponential functions. So in the videos, we looked at the basic exponential function, which would be this one. We have an asymptote on the x-axis. We cross one above that. We go up on the right and down on the left, getting really close to that asymptote without touching it. This is our basic exponential function. If the base is higher, then it's going to get steeper. If the base is lower, down to 2, it's going to be more like a ski slope. All right. If you have a fraction, so this would be like 2 to the x, 3 to the x, and so on. If you have a number that's less than 1, it's going to reverse it. So if you have like 1/2 to the x, that's the same as 2 to the negative x using our exponent rules. That's going to be a reflection around the x-axis. And then if you put a negative out front, if we put a negative out front, that's like parabola up, parabola down, that's going to flip it downward like this. Oh my goodness, sorry, I don't know if that's my tablet or my hand, it's going a little crazy. I might need new batteries here. Okay, so those are the two major variations where we've got reflections, but we're going to stick to this one where we've got a base of like 2, 3, 4, 5. So most of the graphing is going to be based off of this. So let's say that we have like 3 to the x plus 2. So 3 to the x, okay, we think of this picture, the starred one. 3 to the x we know looks like this. The plus 2 is inside the exponent. That means it's inside the function. Remember, inside is left and right, and it's opposite what you'd expect. So this is going to take us to the left by 2. All right, now how do we shift this? Well, it's going to move every point to the left by 2, but really the only point that we have that's a key point is this one right here at 0, 1. So the two things that we're going to shift when we're doing these graphs, we're going to shift the asymptote and we're going to shift that point. So if we go to the left by 2, the asymptote doesn't shift because it's infinite. And then instead of crossing 1 here above that, we're going to go to the left by 2 and we're going to cross here. Okay, well, not cross because there's no axis there, but that's going to be our key point there. And then we're going to go up on the right and we're going to go down on the left. All right, so you kind of have to understand what's going on, because when you look at these in your graphing calculator, they're all going to look pretty much the same. It's kind of hard to tell what's going on just from the picture. So as long as you understand that the shifts are going left and right, then the picture will make sense. Let's try another one. Let's say we've got 4 to the x minus 3. 4 to the x minus 3. So 4 to the x we know looks like this one, the starred one on the left. The minus 3 is not in the exponent, it's outside the exponent, so it's going to be a shift up or down. And we're going to shift down 3. All right, now when you shift these, shift the asymptote first, okay? Because we're not, the key point is not 0, 0. The asymptote's on 0, 0. Our key point is 0, 1. So when we shift this down 3, shift the asymptote down 3, and then our graph crosses 1 above that. The graph crosses 1 above that. So it looks like that. So this is a key difference from our other graphs. When you shift down 3, that does not mean that your graph is at 3. Again, that does not mean that your graph is at 3. It means that you shift all the points down 3. Since our graph is not sitting at 0, 0, our graph is not going to be at 3. Our asymptote is going to be at negative 3. Our graph is going to be 1 above that at negative 2. Okay, so be careful, be really careful about that. The graph is at negative 2, the asymptote is at negative 3. Okay, and that's the biggest thing about graphing them. Let's look at solving a couple of these equations. So the key here is that they're 1 to 1. So if you have two exponentials that are equal, then the exponents have to be equal. Okay, so the exponential function is 1 to 1. That means if the y values are equal, then the x values have to be equal. If you have different y values, then you've got different x values and so on. So the basic idea is that if you have, let's say we've got 6 to the x equals 6 to the 2x minus 3. So we can see here the bases match. If the bases match, the exponents have to be the same. So since our bases match, the exponents have to be the same. So that's going to give us x equals 2x minus 3, and we solve for x. So we can move this to the other side. We get negative x equals negative 3, which means x is 3. And you should be able to go back up to the original equation and check that. We've got 6 to the third equals 6 to the 6 minus third, which is also 3. 6 to the third equals 6 to the third, and it checks out. Let's try one where they don't match. Let's see. Let's do 4 to the x squared equals 2 to the x. Okay, so this one does not match our property because the bases don't match. The bases have to match in order for this property to work. So the first thing that I have to do is I have to get the bases to match. So I can rewrite 4 as 2 squared. Okay, I can rewrite 4 as 2 squared. I haven't changed anything. And then exponent rules tell me that I multiply the exponents in this case. So I get 2 to the 2x squared equals 2 to the x. Okay, so I use exponent rules to simplify this. I get them to the same base, and then I multiply the exponents. Now the bases match. Now I can look at the exponents. I get 2 to the x squared, 2x squared equals x. I need to solve this. This is a quadratic. For all of these, you should be able to move them to one side and factor. So let's move everything to one side. And we've got a common factor of x. And we can break this up. X equals 0, 2x minus 1 equals 0. So x equals 0 is one solution. And then this one we can solve. And I'm just going to have to write the answer here. The answer is 1/2. Okay, so for this one we get 2 solutions. You can come back up here and check. You can put these in your calculator. 0, you should be able to check. Anything to the 0 is equal to 1. So these are both equal to 1. And then 1/2, you'd have 4 to the 1/4 equals 2 to the 1/2, and those are the same as well. All right, let's try one more of these. Let's do one with e, because I think those tend to be a little bit scary, but they're really not. So let's say we have e to the 4x times e to the x squared equals e to the 12. All right, so in the videos we talk about e. Remember, e is just a different base. It's kind of like pi. It's 2.7. All right, nothing to be scared of. It's just a different base, different number, and it works the same as all these others. So the key to all of these is we have to get the bases to match. The nice thing about e is that the bases have to match. You can't rewrite e as something else. So for these problems, they'll all match. They're all e. We're good. We don't quite look like our property though, because, whoops, I accidentally set up the video. We don't quite look like our property because it's got to be exponential equals exponential, and we don't have that. We've got 3 exponentials. So we're going to have to do something here on the left first. Exponent rules in this case tell us if the bases match, we add the exponents. Okay, so over here or here, we had one base and we multiplied the exponents. Over here, we have matching bases and we add the exponents. Remember your basic exponent rules. Those are going to be important here. So we can combine these by adding the exponents. Now the bases match, which is the nice thing about e. And all we care about now is that the exponents match. So that gives us 4x plus x squared is equal to 12. So even though it started with e, it really has nothing to do with e. We just have to get them to match, and then we're good to go. Again, we've got a quadratic. We should be able to move everything to one side and factor. X squared plus 4x minus 12 equals 0. And this factors is x plus 6, x minus 2. Double check. They multiply to be negative 12. They add to be positive 4. And that's going to give us negative 6 and positive 2. To check these, you're going to have a calculator, and the numbers are going to be pretty big. Yeah, the numbers are going to be pretty big. E to the 12 is going to be huge. So hopefully your calculator can handle that, but you would definitely need a calculator to check those. Okay, and that's the basic idea for solving those. You've got a few examples in the regular class videos, and now you've got a few more examples if those help.